Hello everyone, my name is Xiong. Today I will introduce a joint model for medical named entity recognition and normalization for Cantemist 2020 task. We participated two tasks of Cantemist 2020. The first one is medical entity recognition that automatically finds tumor morphology mentions. The second one is entity normalization that return all tumor morphology entity mentions together with their corresponding codes. We will introduce our methods and the results firstly. We proposed a joint learning model for medical entity recognition and normalization. This is our model framework. Next, we will introduce each part one by one. For MER task, we recognize it as a machine reading comprehension task. We use a guideline definition of entity type as question and each sentence in EHR as context to get answer span. We find the start position and the end position of the answer, which is the entity we should recognize. We define the task in the following equations. The loss of our MER is the sum of start position loss and end position loss. For the MEN task, we use the same sentence representation as MER. At the task layer, we convert it into a multiple sequence labeling program. We know that the normalized tumor code has a hierarchical character. The first 4 digits are tumor or cell type. The 5th digit is behavior, and the 6th digit is differentiation. And the last one is added by the organization, which is some tumor mentions contain a relevant modifier not in the terminology for this concept. We use a sequence labeling method, and each word is classified by 3 classification model. We combine behavior and differentiation part as one classification model, and the loss is the sum of each classification model. The total loss is the MER loss and the weighted MEN loss. The overall performance of our model on MER and MEN is shown as follows. When the loss weight lambda is 0.5, we got the best performance of MER, which F1 score is 0.87. When the loss weight is 1, we achieve the best result of MEN, which F1 score is 0.825. We compare the pipeline method and the joint method for MER and MEN task. We can conclude that the joint model brings improvements over MER and MEN tasks, and MEN has 4.3% F1 score improvements over the pipeline method. Besides, when removing ubiquitous code 8006, donated has no meta-statistics. The performance of MEN has slight change on precision and recall, but the F1 score is the same. The pipeline method has a decrease on F1 score, which indicates the robustness of the joint model. The next session is our discussion. For MER task, there are following errors. First, long-tail problem is a main obstacle. Our model can just recognize few entities of long entities. Second, our model is hard to recognize nested entities because of their rareness in Chinese set. Third, there is a specific case. When sentence has structure A and B, our model is difficult to recognize which one is entity. For MEN task, we further separate the behavior and differentiation part of tumor code. The F1 score of MEN on development set decreases from 0.794 to 0.708, indicating the relationship between their two. Maybe they have relationships between other parts of tumor code. In the future, we want to use knowledge graph to assist the system to solve the long-tail problem and explore how to detect the relationship among different parts of tumor code automatically in the model. Thank you for your listening. If you have any question, don't hesitate to contact with me.